Welcome, wonderful people. This is Mr. Ndabezita, and if you remember very well, in the last tutorial we dealt with strongly typed collections, and we dealt with many things that are inside here. This is a strongly typed collection because we had to create an array list so that we can access the remove, the range, the remove, add method, and so on. So this is a strongly typed collection. Now what we want to do this time, we don't want to do this mighty work that we have been doing here. We just want to simplify things a little bit. And how do we do that? Now we are going to look at collections in a different way, not strongly typed, but the simplicity of how we can achieve without having to do that mighty complex work we did in the previous tutorial. Now it is very important that we start first with a text so that we understand exactly what we will be dealing with. Now in the definitions of collections, they say now that you know what is possible using more advanced collection classes. This is exactly what we have been doing. We have been dealing with advanced collection classes. So this is very advanced. This is so much advanced. Do not look at this and think this is playground. This is advanced. In C# language we call this the advanced strongly typed collections. All right, so they say now that you know what is possible using more advanced collection classes. We saw that we can add, we can remove, add. We just looked at a few things, but there are many things that we can do with these strongly typed collections. All right, now it's time to create your own strongly typed collections. Okay, one way of doing this is to implement the required method manually. This can be time consuming. We know that. Okay, that it's fine. All right, but this can be time consuming and complex. It can be a very complex process. Alternatively, you can derive your collection from a class such as the system.collections.collection base, and this is exactly what we are going to do, because they say alternatively you can derive your collection we will derive our collection from that import. And they say an abstract class that supplies much of the implementation of the collection for you. So this collection.collection base, it's an abstract class. You cannot instantiate it, but you can inherit from that. So hence we will see how this inheritance will work. All right, so and this option, it's strongly recommended, this option of deriving much of these things from the collection base. Okay, what is this collection base now? The collection base, okay, let me do this. I think coding always simplifies a lot of talk. So let's allow the animal to inherit from the collection base. If animal inherits from collection base, all of the public methods and fields and everything that are inherited inside of the collection base by the animal, chicken and cow will also have access to that. So that is why we are inheriting, animal is inheriting from the collection base, because the family is linked to animal. Very important. Now the collection base class exposes the interfaces IEnumerable, ICollection, and IList. This is very important. It exposes the interfaces and then let's just do this. These interfaces are enumerable. Secondly, it's I collection, and lastly, it's the I list. Very, very important. This is the function of this collection base. It has these three interfaces. These interfaces are enumerable, I collection, and I list. So we will have access to them. And individually, these are classes. Remember, an interface, it's a class. Just that an interface, we cannot create concrete objects. We cannot instantiate an interface. So even the collection base, we cannot instantiate that. So it acts as the parent, and these you can see them as the children of the collection base, but they are interfaces. You can have only the methods inside of the interface, but the class that inherit from the interface must provide an implementation of those methods. This is our basic understanding when it comes to the interfaces. Okay, that is fine. So we have this enumerable, I collection, and the I list, but provides only some of the required implementation. So it doesn't provide everything, some of the required. Notably, which is the clear and the remove at methods of the I list. So the I list allows us to clear and remove it. This interface, when you use the methods which are clear and remove it, you must provide an implementation for that. You must implement the clear and the remove it of what now, of this I list, because it is an interface. Very, very important. Okay, that is fine. And we have the count property of the I collection. So we have a property which is the count property of the I collection. Okay, that's fine. And then you need to implement everything else yourself if you want a certain functionality provided. Okay, that is true. We will do that. To facilitate this, the collection base provides two protected properties that enables access to the stored objects themselves. You use the list, which gives you access to the items through an iList interface, and inner list, which is the array list object used to store items. This is very, very important. So first of all, we are saying collection base. This is very important. We are saying the collection base provides two protected properties. It has or provides two protected properties. If these properties are protected, we don't have a problem with that because we are using inheritance. We know that protected properties or members can be accessed even outside of the class where they were derived, because we know with protected properties they will be accessed within the family members, just as the fields. We looked at protected properties and protected fields, and we know that they will be available inside of the chicken and the cow. We know this. So we are saying that the collection base has two protected properties. Very, very important that we understand that. So it has those two protected properties that enable access to stored objects themselves. Two properties that allow access to objects that are stored. Very, very important that we note that. Secondly, what is it that we need to note from this? All right, you can use the I list, which gives you access to the items through an iList interface, and the inner list, which is the array list object used to store items. So the list gives you access to items through an iList interface, and the inner list, which is the array list object used to store items. Okay, that is fine. And then let us just try to continue with this, and then we have indexes and so on, but we will look into that. So we have this animal, public animal, that inherits from the collection base. We were just trying to gather some notes so that we try to understand what is happening here. Now the first thing that I'm going to do, I'm going to declare a public method that will return void, and I'm going to call this method add, and this method accept an object animals, which I will call a new animal. So remember what we said. We said the collection base has two protected properties that allows access to the object. So I'm adding this method accept an animal object, which is called new animal. Very, very important. And then what am I going to do there? I'm going to use the fat arrow instead of using the curly braces, and I'm going to say now list dot, and immediately when you say list dot, look at what we have access to. We can add, we can remove, add, we can check if it contains, we can clear as parallel. There are a few of things that we can check here, that this dot this sync the root of type is synchronized, is read only, and so on. But we want this method, which is add. And what is it that we are adding? It adds an item to the iList. And then what is this value? The object to add to the iList. So it has to accept, the method needs to accept an object, not a string, not anything else. So it has to accept an object because it adds that to the list. It must be an object. Hence, in this method, I am accepting an animal as a parameter, an object, which is called new object, so that I can pass that object inside of the iList. So I'm going to say new animal, and it will be very much satisfied with that. So we remember, this is an interactive learning. We are not here to master everything and get distinctions without understanding exactly what is happening. We are here to understand coding, so that even if you are in the exam, even if you have an assignment, even if you are at work, you understand exactly what you are dealing with. And even if you make mistakes, you can be able to trace and see why the mistakes are there. Because I will tell you one thing, many things has happened with students during the COVID-19. Exams were written online. Many people have distinctions with empty brains. So let us continue with this. So we have this public void, and we have this method, and you understand exactly what is happening there. I have already explained. Right, and then secondly, what we are going to do, we are going to have a public. This is also going to return void, and I am going to call this method remove. And I want to take your attention here. These methods that we are having, didn't we have these methods inside here? The add and the remove, we had them. But we had to create an array list and create objects first that will allow us many things. So this complex coding we did here, we are trying to simplify that using what? A collection base. Very important. So we have this remove, and this remove will also accept an animal object, which I will also call new animal, and then I will use the fat arrow, or somebody might use curly braces. It just depends on the version of C# that you are using. So dot, and then we are removing. We are not removing it, we just remove. And the remove also accepts an object to remove from the I list. So let's pass in the object which will be a new animal, and everything is fine. Once that it's done, we understand exactly what is going to happen there. Okay, from there now we need to use an indexer. Let me just declare this indexer public animal. So this looks like it looks exactly like a property, but I want to show you something. I'm going to say this, and I'm going to use these brackets, and I'm going to say int, and I'm going to name this animal index. And once that is done, I'm going to have my brackets like this. So here I'm not going to use the fat arrow. Now what is this? This looks like a property. This is exactly what it is. It is not a method because we don't have this. Please be careful. Please be careful. It's not a method, it's a property here. So so let's call this an advanced property. Advanced property indexer. All right. Now, what is this indexer, Mageb? What are you doing here, Papa Fanzo? Now, let us read what an indexer is. An indexer is a special kind of property. So let's not say it's advanced. Let's say it is a special. So this is a special property indexer. An indexer is a special property, kind of property that you can add to a class to provide an array like access. So it is a special property indexer that does what now? That provides an array like access. Very important. In fact, you can provide more complex access via an indexer because you can define and use complex parameter types with the square brackets syntax as you want. Implementing whatever, okay, this is not important. So what are we doing there? Okay, we understand that this is a special property, that's fine. And then this property instead of having int or double or char, we are having a class here. All right, what is this going to help us with? This keyword is used along with the parameters in square brackets. So we have one parameter in square brackets, and this parameter is of type int. Right, very, very important. And when you click in here, this is just an int which we call an animal index. It's not an object, it's just an int. Right, this is and then we are saying that this keyword is used along with the parameters in square brackets, but otherwise the indexer looks much like any other property. That is true. This syntax is logical because you access the indexer by using the name of the object. So we are how do I put this? We are accessing an indexer using the name of the object. So I want to access this indexer using the name of the object. So I will have the name of the object there, and I am accessing this indexer via the name of that object. This is exactly what they are saying here. Using the name of the object, so I will have this object here, the name of the object, followed by the indexer parameter, followed by the index parameter of type int. in these square brackets. Okay, that's fine. We understand what the indexer really does. Now remember, because it is a special property, it must have at least a get or a set or both, because this is what the properties possesses. So I'm going to have a get, and the get will return. What will it return? So first of all, remember, this is an object. So when you say return here, you must return an object. So what is it that you are returning? You are returning animal. You are returning animals, and then you say list of what now? Of animal index. Of the animal index. And we are closing that with a semicolon. Tab, very good. Let me have a set even in here, and then I'm going to say the list animals, it's equals to the value that you assign, the object that you assign there. Right, what do we mean by that? It is very important that we explain that. Right, we explained that this keyword, that is fine. The indexer code uses an indexer on the list. The indexer code uses what now? The indexer on the list. So you must say return, this is animal, right, an object, and then it uses what now? The indexer code uses an indexer on the list property, that is on the iList interface that provides access to the array list in the collection base that stores your item, and it returns the animal list, and then inside of these curved brackets, that is the animal index. So let me just try to explain this in a simplified way that I understand it to be. Right, this is the return that we have. Okay, let me just press the tab there, and then let us check here what is happening, because you see that we have casting here, which is implicit. We have implicit casting here. We are casting, right? Implicit casting is necessary here, as the iList.list property returns a system.object. Yes, it returns an object. The important point to note here is that you define a type for this indexer. The type will be an object type. We are defining a type here, that the type will be an object type. This is the type that will be obtained when you access an item by using this indexer. This strong typing means that you can write this code in this way. Right, now let us go and check. So we are saying set, and we are saying in here, remember we have a get. Okay, let me just fix this, and then we are saying the list, which is an animal index, is equals to the value there, right? And then we must use these types of brackets just as they have used them there. So what we are doing, remember, we want to initialize, we want to have a get and a set of this property that returns an object. So public, it returns an object, and this object must be the object that comes from the animal. Okay, that is fine, via inheritance, because we know that this class, it's let's just go and check this class. It's just public, but it's fine. It's fine. We could have declared this class, yeah, it's public. Okay, it's fine. So we will be able to instantiate an object of this class. So we are therefore saying here, it returns an object. We explained what is happening here. Now remember, with a get returns what now? It has to return an object. Right, so we are casting. This implicit casting is necessary. It returns an object. I'm casting to this list, and then remember the list. When I declared this list dot add new animal, so the list accepts what now? It accepts an object. Very important, it adds an object. So when you are here, you have a parameter of type int, right? But remember that it returns an object. So you are saying animal list, and you are sending in this animal index, the position of this animal, and then it will go to the position, because when we run here, converting non-literal or possible null value to a non-nullable type, possible null reference return. Okay, that is fine. So what we are saying, if this is the index, animal index, the position where the object is, it will take that, remember, that specific index where that animal is, and then it will take that to the list, and then it will return an object. There's an object at a specific location, 012. You have an object there. You are specifying where the object is, and then it will add that to the list, and it will go and return what now? An object, not a number, an object at that specified index. I've tried to explain. And then what are we setting now? We are setting the value that you insert here. The value that you are inserting here, you see it says now parameter animal value. And what value is that? It's an object, because I know that at a specific index I have an animal value 0. So when, for example, I say 3 here, value is not null here. This refers to an object. So when it says that value is not null here, it simply means value there is an object that is stored inside of what? Of the value, and it will take that object and assign it to the list of what? Animal index. So this has an object. This is just us trying to explain that. So this is the get, and this is the set that we have. Right, now I can go inside here and I can remove much of the work that we have done. Let me just remove that. Let me also come here and try to remove many of the things in there. Let me also remove you, and everything seems to be fine. Everything seems to be working fine. So we are here now in the main, and we want to do some modifications. So I'm going to go to animals, because remember it is public this time. I can instantiate, I can create an instance of animal. So I'm going to say animals, and I'm going to call this animal collection. Animal collection, it's equals to new animal. Right, let's go and check the constructor inside of animal. Now I have a constructor in here, and where is this constructor? Public animal, and this one, oh sorry, this one is a property, sorry. Do I have a constructor that accepts any arguments? No. This is a property. This is a method. So a default constructor will be set for me here. Right, and initialize the values with null because they are objects, they will be null. All right, and then the second thing that I want to do, I want to say animal collection, and I want to say dot. And then what is it that I want to do here? I want to invoke this add because I have this method inside here. There it is. And this method accepts what now? It accepts an object and add that object to the list. So I'm going to say add. And what is it that I'm going to pass there? I am going to send in there a new object of what now? Of cow. New cow. Very important. And I know that cow must accept one argument of type string. And what am I going to call that? I'm going to call this a Donna. And I'm going to close that. Now we are having a problem here. Let's go to cow. And then we know that cow inherits from this. Okay, one thing that I'm going to do there is just I have got rid of some things in here. Now remember, inside of this class we had some few things. Now remember, inside of this class we had a constructor. Let me do this, public void. I had a method, sorry, let me just do this. I had a method that was called feed. So feed, and this method accepted no parameters, and I just said, I have forgotten now. Okay, let me just quickly go back and just find that very quickly. I forgot the methods that I have set there. Okay, I had a protected string. Okay, let me just do this. In fact, let me just come up here, but I can just do it here, it's also fine. So remember, I had a public abstract. Okay, I had a public protected string, which I called name. Very good. And I had a public, okay, let me just fix this. Protect more than one protection modifier. Okay, I had a protected, I'm sorry, I had this protected string which was called name, and I also had a public string, which this was a property, and this property was like this. I had a get that would return the name, and I also had a set, and name was equals to the value that you attach to that. You remember we had something like this. And then what is it also that we had? We had a public constructor animals, and let me just go to chicken. Okay, let me just use an S there. Let me go to cow, and let me just use an S there. Let me go back to this. I had this constructor, and I used a fat arrow, and what I said was just to say that name is equals to the animal with no name. The animal with no name. This is what I said. And then I had another public animals, but this one accepted a string that I said was new name fat arrow, and I said that name is equals to the new name that will be passed in. And then what is it that I also had? I had a public method which was returning void, and this was called feed, and it accepted no parameters equals or greater. And I had a right line, and the right line just said let me just use interpolation, and it just said name has been fed. So this is exactly what I had inside of the animal. I had this. So let me go, everything is fine. Let me go, everything is fine. So I can return to the program now. Right, be that as it may, we are now inside of the main. Right, when we are now inside of the main, what is it that we want to achieve inside of this main? So we have this animal connection.add. We added that to the collection. And then secondly, I want to add another one because I have two animals, animal collection.add. And what is it that I am adding now? I'm adding a new chicken, and I know that chicken accepts a string, and I'll just call that Mary, and then I will be fine. Now I can use a for each loop, and then in this for each loop I will say animals, and I will call this my animal in animal collection. Very good. And then I will just say my animal dot, and I have access to this method feed. Right, and then I will try to have a read line there. So let us try to run this and see exactly what is happening. Let us try to run that, and let us try to run this. So we have simplified things a lot. So this is one way of using the collection base, and it is very helpful. It requires that you sit down and you practice these things. We cannot just understand these things in 1 day or 2 days. Coding is something that you need to breathe and eat every second of your life. It's like worshiping Yeshua. You see, you cannot do without Yeshua. All right, Donna has been fed and Mary has been fed. So we see that I think we understand what is happening there. I have explained many of the things that you saw in there. And then in the next tutorial we will look at many things like the keyed collections and the dictionary, and we will look at things like iterators, and then we will continue and we will implement them and see exactly how they work. And then from there we will look at iterators and collections, we will look at the deep copying, we will look at many things. So thanks a lot guys for watching this tutorial. I will see you in the next tutorial.